Welcome to New Breakpoint, a series for developers by developers. My name is Michelle Sandford and I am the Developer Engagement Lead for Australia, New Zealand and Asia. We broadcast on the second Thursday of every month, and if you join us live, you can ask questions and then my guest and I will answer them for you during the show. And of course, you can watch this episode on demand and on YouTube after the fact. Today, I am thrilled to welcome back the fabulous Graeme Foster, Microsoft Senior Azure Technical Specialist. Graeme, give us a little insight into your role here at Microsoft. What do you do?
Hey, Michelle, and thanks to having me back on here again. You're never sure if you're going to get an invite back to these things after you've done your first one. So it's really, really cool to be back here. So at Microsoft, I've spent the last few years working in our applications space. So my background is really many years as a developer. So I love building applications, helping people with their CI/CD processes and things like that. And I get to do that at Microsoft. So basically, we have got a really great suite of application services like Kubernetes and Azure Container Apps and GitHub Actions, all those kind of things. And my job is to help customers to really leverage those products and to use them to get the outcomes that they need.
Awesome. You are back by popular demand because it really was an exciting episode that you did for us in season 3, and we talked about LangChain and semantic kernel. Today we're going to be talking about GraphRAG. Is that in any way related to those two previous topics?
I think it is. It's all still large language models that I want to talk about today. So when I came in on series 3, we did a little journey, which was from assuming you've never really heard of GPT and you've never seen it used before. And it was like a little journey in showing you how you could leverage it and what you could use it for. And part of what we did in that journey is we showed kind of how to build these little applications that can chat over your own data. So, we see them deployed all the time at customer sites at the moment. You might have help desk documents, you might have a whole ton of documents that's laying around. And you might have, let's say, your customer support center, and they need easy access to all this information. And one of the really great use cases we've seen of LLMs is a way to take all of that information and to bring it all into different, we call them vector indexes. We talked about this the last time, but we'll have a look at it again in a few minutes, such that you can chat over it. So you can have a nice little human-like conversation and say, hey, can you tell me about the process for doing this? And we can leverage the LLMs to go and fetch that information and present it to us nicely. So we're going to be moving on from that again today and showing some cool new things that are happening.
One of the things I think a lot of people get confused about when they're first starting to build with AI is how the model is going to know anything about their data. It hasn't been trained using their data, but those, generative AI models are already enormously trained on a lot of knowledge. Is RAG what we are using in order to link that data or get that data out while still using those models?
Yeah, great question. RAG, as a reminder, stands for Retrieval or Augmented Generation. And I think, why don't we walk through an example for like a little bit of a recap so we can see where we left off last time, because that's going to, I think, enable us to start to see what kind of problems customers might be facing that are using this technique that, let's call it BaseRAG. Over here. So, we talked about RAG. I think we called it RAG in season 3, which is probably a bit of a generalization, really, because what we're seeing happen is that RAG itself is an idea. And what we showed in season 3, which we'll go through now, is a very simple implementation of RAG. And to address other issues, we're seeing different ways of approaching RAG coming out. So I'm going to refer to it as BaseRAG now. And let's walk through what we got up to. So I'm going to use VS Code here to demonstrate this. But if you remember in RAG, what happened is we started off with all of our unstructured data. And what we did is we used this really cool concept in large language models that were called embeddings. And it's all coming back, isn't it? It's like, yes, all these words. And the general idea was that because large language models have got some limitations over the amount of information we can actually pass into them, we can't just send it our entire procedures or our entire policy document and say, hey, answer this question that the user's got. So what we do is, in BaseRAG in particular, is we use this simple process where we take all of our documents and we snip them into little chunks. And then ahead of time, we ask the large language model to create what we call embeddings on those chunks. And the embeddings are, think of them as like long lists of numbers that describe the semantics of that information. So we're not talking words here, we're talking kind of meaning and concepts and things like that. And the idea is we can take all of these little chunks and then get these embeddings and store them in what we call a vector index. So this is the kind of like start of our RAG pattern. And the idea behind it is that if a user asks a question, then we need to retrieve the best information that we can find to help answer that question. So this is the stage we're looking at the moment.
So I think when we talked about this last season, I said it kind of, RAG reminded me of a mind map. But I think I might have been giving it a little bit too much credit when I called it that, because it's more like when you're in the library and there's those sort of index cards that can look up, where is the book in the library and what is the author, and maybe it could, bring information back from that book, but it's a little bit more sort of this to that, as opposed to the mind map thing. And the reason I want to clarify that up front is because I think what you're going to get into is a lot more like a mind map than that.
Yeah, right. There's definitely a spoiler alert going on there, but you're absolutely right. In the BaseRAG is fairly simple in what it does. It literally takes these slices of information and it stores them in a way that we can take a user's input and say, is there any information that was similar to what the user's asked? And I think similar is the key word here, right? It's like BaseRAG uses a similarity search. So, it has got really good situations that it can work in. If we run through a little example here, then I've got a little library that I've written in the background just so I can hide some of the kind of horrible code away from us. You don't want to see my code on these things. It's really quite disgusting. But here's the general idea. Like, we have a user query. For what it's worth, all throughout this demonstration today, I'm going to be using a document that I found online in the, is it the Gutenberg or something like that? It's a open source repository of public information documents. So this is all stuff that doesn't have copyrights on it and things like that. And there was this really interesting document about Leonardo da Vinci. And I chose it because I think it might help us to show some of the problems that BaseRAG and people using BaseRAG might be having today. But it's essentially a document about Leonardo da Vinci, his birth, his life, his training, his artworks, and things like that. So going back to my little query, what we've done is we've basically broken that into lots of small chunks. And I'm going to start off by just taking my query, what paintings did Leonardo make, be exhaustive with the content you're given. This is just my way to try and make sure the LLM responds how I want it to. And we're going to start off by creating the embeddings. So that's how all BaseRAG starts. Now, what happens next is we're going to use our vector index to basically take or tell us which chunks of information look similar to that user's query. So we might have chunks that talk about Leonardo and paintings. We might have chunks that talk about artwork, things like that, concepts that are similar. And we're essentially going to get a list back from the search index saying, yeah, I think this chunk, this chunk, this chunk, and this chunk. So what we'll then do, actually, I should actually write something out here so we can see what comes out of here. We'll take those chunks and we're going to feed them back into the large language model and say, hey, I found this information and I think it's going to help us answer the user's query. So give me an answer. Give me something that we think makes sense. Because this is, I've got to be a little bit careful, right? Because I'm using Leonardo da Vinci here. And Leonardo da Vinci isn't exactly a niche kind of topic. So if you think about LLMs, because they're trained on so much information from the internet, there's a very good chance that the LLM knows all about this stuff anyway. So I've been quite particular with my query when I send the information back in, saying you must only use the information I provide you here, right? We call this grounding in an LLM, and it's particularly important if you're searching over your own private data, because what you don't want is the LLM kind of starting to reach out into the wider world and, maybe bring back its own information on profitability or interest rates and things like that, when you're just interested on your own information. Okay, so what I've done now is I've taken all those chunks and I've said to the LLM, like, yeah, this is grounding. Give me an answer based off just my content that I provide you. So it's a really important concept. And like you say, it's referred to as grounding. And when we do that, like, here's the output. So I've basically been given some output about Leonardo da Vinci's artworks that he's created. And in this case, let's have a look how many we've got out. We've got 10. So I've just taken the first few chunks that the search thought were useful and passed those in. Now, this is really good, right? It's kind of nice, but I'm interested. I know you work with people that use BaseRAG yourself, Michelle. Have you heard any people say, like, it's okay, but there are scenarios where it's not quite working for me?
Yeah, actually, I was speaking to a partner at an event the other week, and they were saying that while RAG is very good, it's not great at the subtleties that they needed, and in order to really ensure it was grabbing all the information, they were trying to build something more. But it sounds like maybe we have a solution for them.
Well, look, so what I would say is that, and I feel like you've read ahead of my little presentation here, Michelle, but we're going to take a little step to get to that outcome, right? Because BaseRAG is actually, if you can make it work, it's got a lot of good things going for it. And I think the main one for me is it's actually really simple to understand and use BaseRAG. Right? There are very few moving parts in it. We take these documents, we split them up, and we search over them, and we throw them to the LLM. And if your answers are in the chunks of those information, and that's a really, really good reason to use BaseRAG, because you know that you can get the answer out of a specific piece of information. So some good examples where this works, right? Maybe we've got product information sheets, and we want to ask, like, what's the interest rate on a starter savings account? And it just so happens that we have a product document that's got that exactly in a chunk of information. Like, that's a perfect case for BaseRAG. Or maybe simple bits of text, like who went out for dinner with Jeff at the restaurant. And maybe we have a chapter in a book and it's literally got those words inside it, like Jeff went to dinner at this restaurant with Sally, right? So again, that's a situation where BaseRAG is going to work really well for it. So what we can do is we can start to maybe enhance it a little bit, right? One of the things we can do to make BaseRAG better is we can add little bits of context to those chunks. So it might be in a book or a product document, we know the product name, even though it's not mentioned in every chunk. So maybe we can just add it into the chunk, right? Add a little bit of extra context that's going to help that search to work for us. There's another really simple pattern. A lot of BaseRAGs, when they're doing the chunking, they'll just count a number of words. And if you're unlucky, then you might split a sentence midway through. And in that scenario, let's say the information you're looking for was actually inside that sentence, then out of the box, you might not find it if you break the sentence between chunks. So a really simple strategy is just called like an overlapping chunk. So maybe we have 200 words in a chunk. And what we do is when we start the next chunk, we just take the last 20 words from the previous chunk. So that should just give us that little bit of extra confidence that we are going to capture complete sentences. So that can really help as well. There's another little technique called a hybrid search. We've talked about vectors a lot here, but let's not forget that for the past who knows how many years, we've had inverse indexes and normal search engines that search over text. So we can incorporate that into our searches. because if the user's entering information and those words appear in the chunks, then we might not need vectors and similarity, might actually find the exact words we're looking for. So search engines like Azure AI Search have got support for what we call hybrid search, where they can run a standard text search as well as a vector one, and then combine the results. It's called re-ranking in data science. I'm not a data scientist. You probably know more about this than I do, to be perfectly honest with you. But that can help us get a much better search outcome if we bring vectors and text. And then there are ways that we can really reduce the search space. So let's say we've got searching over a product set, but the user knows what product they want to search over. Well, if we can structure our search index so we can just remove every other product from even being considered, then again, that's going to narrow down the amount of information we have to search over. That should get us a better result. And then there's a couple more techniques. So we've got things like document intelligence. So let's say, for example, that we have got images inside our documents we're chunking. Now, what we can do is use services like Azure Document Intelligence or GPT-4o Vision to actually pass those into the indexes and say, look, what is in this image? And a large language model can come back and actually give us a description of what's in that image. And then we can bring that into our chunks as well. So I think, when we start to take this thing into account, we can actually really elaborate on our BaseRAG. So instead of just taking the chunks, we can extract images, we can extract extra meaning, we can do overlapping chunks, we can add bits of context in there like the chapter, and that could give us a good outcome without having to reach in the toolkit for something more complicated.
So this might be what they were talking about when they said they were having to do more than just BaseRAG.
Yeah, very possibly. But this is going to take you a certain way, right? It's going to get you so far. But then I think a lot of customers are going to hit a point where you start to hit the limitations of BaseRAG, right? And I've listed some of those here, and they pretty much come down to what you said earlier, Michelle. So BaseRAG really struggles in a few scenarios. The first one is where we have like meta questions. So I think you mentioned it earlier perfectly when you said, what are the themes or what are the general concepts in this document? Now, if you're thinking similarity, there aren't going to be words in a document talking about themes and concepts. And, that makes it very difficult for a BaseRAG approach to actually help us here, because the best it can do is find chunks of information that it thinks have got the information, the right content to answer the question. So that's a case where BaseRAG really, really struggles. We have other scenarios where maybe the question requires information that's scattered throughout the entire document. So 3 chunks isn't enough, 4 chunks isn't enough. We actually need the entire document. So if you're thinking like a story like Alice in Wonderland, let's say we say, oh, who did Alice interact with in the story? You're going to have to read every chapter and extract knowledge from every chapter to be able to answer that. And again, with BaseRAG, we can't do that. We'll probably find a few people she interacted with, but it's going to miss a whole bunch of them because we just can't pass everything in. And then we need similar words or concepts. So we mentioned this earlier. Vectors and embeddings are all about similarity searches. So we need the text to match up and we need the words to kind of be similar in some way. And, if that's not the case with the query the user's entering, then again, BaseRAG is going to actually struggle to find us information.
So it's not there for the subtlety. It's all about the explicit information.
Absolutely. Pointed questions, we can ask them in language that's different to the document, but really questions where we can just grab the answer from 1 to maybe 3 chunks of information. Perfect for BaseRAG. And we can get it to a certain place where it's probably good enough for so many use cases. But after that, we're going to need something different. And, I want to introduce the knowledge graph to you. And that's really what we're here to look at today.
This is the exciting part, the part we've all been waiting for.
Exactly. And you kind of summed it up earlier, right? Where you said, we kind of need a way to be able to almost process the entire document to be able to find the information that we need to answer a query. So what if we could find a way to, in advance, extract that kind of information from the document. So we're talking entities like maybe people and places and objects. We're talking relationships, so relationships between these entities. If we could get all of that out of a document in advance, then that might give us a really powerful way that we could interrogate the entire document given a user query to help us answer these more like meta questions. So I earlier introduced you to that little document about the life and works of Leonardo da Vinci. So what if we could start to produce something that looked a little bit like this, where we're actually capturing information? So you can see here, I've got Leonardo da Vinci at the center of the document, and we've got all of these other entities that we've extracted, like he worked at the Ludovico Sforza, he was influenced Piero della Francese, and you can see there's this wealth of information, right? So there's so much that we've captured here. But there's an issue, there's a problem. How do we get this out? It's almost a dangling question there, isn't it? How are we going to do that?
How do we, Graham?
How do we get it? And in the grand scheme of things, we're talking LLMs, right? So at the end of the day, we have got the most powerful language processing unit on the planet that if we feed it bits of information, we can ask questions of that. So what if when we start off with those chunks, the same chunks we had earlier, we actually just throw them to the LLM and we say to it, hey, can you come out with all these chunks for us? So I've got an example query here, which was a book analysis expert. And, you can see your job is to identify all the people, places, things in a book and return as a list of entities and relationships. So we're taking all the good stuff we've learned about prompt engineering, and we're using it to our advantage to basically extract all this information from the graph and return it in a nicely structured way so that we can start to use it.
That looks like a database, Graham. So
it's like a database.
Is what we're saying that this GraphRAG is able to look at stuff, unstructured data, and kind of make its own database of the information?
Yeah, you know what? It's absolutely spot on. And I'll show you a database technology in a minute that's been around for a very, very long time now. But in essence, it is a graph database. And these things have been around for years. And they're useful in scenarios where, let's say we, think of like a supermarket. Maybe they've got their customers are buying things, and they need to somehow advertise to these customers, hey, we think you'd be interested in buying this because your friend bought this at the same season last year. And it's all these little bits of information that look disconnected. And graph databases give us a way to bring all of that together and add structure to it so that we can start to ask questions over it. So you're absolutely spot on. We're basically using the LLM to build as a graph database on the fly that represents the content we want to search over. So the queries down here, I've used some one-shot learning and things like that to basically prompt the LLM to go and get this information. And to show you one of the chunks, like this is what it's come out with. So a whole bunch of entities like Leonardo da Vinci, he's a person. You can see that it's pulled out all this information about the entities, the portraits, the paintings. And if we go further down, then you'll find that we've got a bunch of relationships. So there's one here where it says there's a relationship from Leonardo da Vinci to a painting called The Head of Christ. And the relationship is created, and Leonardo painted the head of Christ. So what we can do is we can take all of this and we can load it into our graph database. So I'm going to take a very quick sidetrack here to show you a little example of what that looks like. So I'm running an open source database called Neo4j. There are other databases. You could use Cosmos Graph database for this. And then there are some other open source ones that you can use in different languages. So, there's nothing special about the one that I'm using here. It just runs in a Docker container on my computer that makes it pretty easy to interact with it. And essentially, I'm going to take this little first query I've got. So this is a query language called Cypher. It's quite straightforward to understand, I think. So we're basically saying to it, I want you to match a person whose name is Francis I, and then return that person. So let's start with that and have a look at what we've got. So whoopsie, grab that. And you can see that we zoom in on a node called Francis I. Now, if I double click on him, you'll start to see that we expand the graph. So we can see that Francis I apparently owned the Mona Lisa. So this is actually a really good example of where you have to be careful. If you look over here, if I click on this, you'll see when I capture the relationships, I capture a reason. And the reason here is the portrait was bought during the reign of Francis I. Now, I think we can both see that that doesn't mean necessarily that he owned it. So like everything with an LLM, it's all about the prompts. So I'm using my own prompts that I've created here, but I am not the best prompt engineer in the world. There are better prompts out there that you can use. But as an example, you can see that we can take the Louvre, which has come up. So Leonardo da Vinci, he worked at the Louvre. We click on that, and then the Louvre kind of explodes out here, and we can see more information around it. If we go for the Madonna, nothing came on that one. What else can we do? The Annunciation. Is it the Uffizi Gallery? We can select that, and then we get more information. And this has all been extracted just by running the prompts over those same chunks. So very similar to BaseRAG, but it's building the graph database up instead. Now, one other thing we're going to leverage is the ability to query and walk the tree in a graph database. So this little query is going to basically say, look, I want you to match all nodes starting at the Louvre, and I don't care what the relationship is, but I want it to be an artwork on the other side. So if I run this, then this is a way that I can actually traverse the graph. So you can see straight away that the Louvre owns the Virgin of the Rocks, and the Annunciation is owned by it as well, and the Madonna, Infant Christ, and St. Anne is in there. So we can build up pretty complex queries to start walking the graph as we need to, but that's the kind of general idea behind what powers GraphRAG. It's this idea of finding elements in the graph that we think are related to what the user's interested in, and then starting to walk out to find other things that are probably useful to answer what the user's interested in. Okay, so I'm going to walk you through, this is my GraphRAG, I'm a poor man's GraphRAG, but I've done a lot of research on the way that all GraphRAGs work behind the scenes, and there's quite a lot out there. We have a Microsoft GraphRAG. You've heard of Llama Index and LangChain. These are all open source frameworks. They're all starting to get their own implementations of GraphRAG as well. Neo4j has one, and they all work in similar ways. And this is how they do it.
I've put some links in the chat in the resources, awesome, so that if they want to have a look at the Microsoft GraphRAG and a little accelerator that we've got, I should say a little accelerator, and a Microsoft accelerator that we've got. It's not in any way little.
Yeah, that's right. It's pretty all-encompassing, actually. So we're going to start off in a very similar way to the BaseRAG. I'm going to take the user's query and I'm going to embed it. But this is where things get different. Now, if you remember in BaseRAG, I went to search for chunks of information that looked similar. Now, what I've done that's different here is instead of indexing the chunks of information, I've actually used an index to go and create embeddings of all of the entities. So every entity inside that graph is inside my Azure AI search with a little summary. So all the information I found about that entity, I've rounded it up, again, using the LLM, into a little summary, and I've embedded that. And what I want to do is use AI search to tell me where it thinks are good places to start at in the graph. Because remember, the idea is we're going to walk it to find information. So I'm going to do that. This is just a standard AI search query. And this returns back, I've taken the top 6 here. So for my query, what paintings did Leonardo make? It recommends I start with these ones. So the Florentine Renaissance, Leonardo da Vinci, Virgin Child with St. Anne and St. John, the Annunciation, the Warrior, and Mona Lisa's portrait. So just a similarity search, like, just, hey, out of these thousands of entities in the graph, maybe these are good ones to start at. Now, the next thing I need to do is to work out, given all of the different types of entities and relationships, what should I pursue? Like, if I'm looking for people, there's probably no point in pursuing paintings in the graph. So I'm going to, again, use the LLM to say, this is the user's query. These are all the entities and these are all the relationships that I know about. Which ones do you think are going to be useful to walk? And it comes back and it says, well, I think you should walk the person entities, the artwork entities, and the painted entities. So this has cut down the scope from hundreds of relationships to just a handful of them. So now we've got the information we need to go back to the graph. We've got the 5 starting points. We've got the entities that we're looking for, and we've got the relationships that we think we want to follow. So the next thing we do is we literally walk the graph. And I won't show you the Neo4j's queries for that, but instead I'll show you what comes out of that. So these are all entities. So you can see the Florentine was an art movement. We've got the starting points. But as we walk the graph, then we start to get more information. So we've got a pen and ink sketch of Bernardo Bandini. So by following from those nodes, following the relationships, we're starting to discover all this information that could be all throughout the document and collate it into a very small, relatively, amount of information. And that's super important because, again, we're still dealing with the context window of our LLM. So we can't throw too much information in there. So that's the retrieval stage of GraphRAG. So instead of taking chunks, we take entities and relationships and extract all of that information from the graph database. And then we perform the RAG. So
it still looks like a lot. I was just going to say, that still looks like a lot. Is that a lot more information than it was getting before? Or is it
great
in
question.
terms of tokens and stuff?
Let's have a look. So here's my first GraphRAG. So my prompt had 1,548 tokens and my completion had 499. If I go to my BaseRAG, my prompt had 2,302 tokens. So there was more going in on the BaseRAG than has gone in on my first pass at GraphRAG by quite a considerable amount. Now there's a caveat here. There's always a caveat. Now this is pretty cool, right? I've got 17 results out. So this is nice because my BaseRAG, I think, gave me 10 results. So I found more paintings that I'm happy about. But what you might see is I've got less information about those paintings because with the BaseRAG, I'm passing bigger chunks in. So there's more context about the paintings. Whereas with the GraphRAG, I'm passing less, just very brief summaries in about the relationships. So a little bit less information. So I've got another query underneath, which actually combines the two. So I take the chunks and I take the entities and relationships. So this one is a bigger query. So 3,741 tokens have gone into this one. But I think I get 17. And if I recall correctly, there was better summary and information inside this one than in my original GraphRAG. And depending on the query, it's sometimes comparable to the BaseRAG, sometimes not. What I would say is, because I'm only searching over a single document, BaseRAG performs really well. Because in my entire database, I've only got like 24 chunks of information. And I'm taking, almost a 1/7 or an 1/8 of all the information and throwing it into the context window. But if you've got loads of chunks, loads of documents, you'll find that like BaseRAG will probably start to perform worse the bigger that data set gets.
Yeah, and not even a single data set. Sometimes when you're within a company organization, you'll be looking at multiple data sources for, the same kind of queries that you're wanting to go over. So you're needing it to connect and contextualize across multiple data sources. And in a sort of flat structure like RAG was trying to do, it seems like that would be Yeah, it would be great on maybe the little questions, but on the wider context things, that would be very difficult for it to do.
Exactly. So what I've shown you now, I'll put all this source code up so you can have a look at this as well, of course, is my kind of homemade GraphRAG. I'm a bit of a glutton for punishment like that. It's like, I don't understand how this thing works. So I'm going to go and build it myself in the evenings so I can pick it apart and try and get my head around the concepts. But of course, you don't need to do that. So I'm going to introduce what we call Microsoft GraphRAG here. So Microsoft GraphRAG came out of a research project, and there's some really good white papers on this. We'll get the links to those as well, that go through the ethos behind it, the approaches that they take, similar-ish to what I've got and I've shown you. But really, they take it to the next level. And the really cool thing about it is that you can be up and going just by using these like 3 lines of Python code here. So there's a pip package called GraphRAG, and then GraphRAG's really cool. I've got my own prompts that try and extract the entities and relationships, but GraphRAG itself will actually tune the prompts for you. So you can point it at your documents, and what it will do is it will use the LLM to say, hey, what are the entities and relationships that I should be extracting from this information? How should the prompts look? And depending on what's in the data set, you'll get kind of like slightly different prompts that come out. So that's a really nice way to get going. And then finally, you tell GraphRAG to go and index your content. And that's where it's going to do everything I've shown you, but it's going to do a couple more things as well. So there's a very, very pretty picture here that I took from the GraphRAG website. And if you think about what I showed you in Neo4j, this is like a graph that's of much more content, right? So all of those node entities, there's going to be tens, if not hundreds of thousands inside this particular graph. But you'll notice that things are colored differently. So GraphRAG has got this extra step inside it where it says, look, all of these nodes and entities, what about if we could try and find what we call communities or clusters of very highly related things inside it? So this is like analogous to Facebook, right? Where if you think about in Facebook, you might be part of different communities where there's very tight, lots of conversation between them, but those communities might be loosely connected to other communities, right? So maybe a couple of people that are in that community, so there's a little bit of connection, but you could almost see them as separate entities. And GraphRAG I think when they were actually doing the research and building it, what they found is that when you've got an absolute ton of information, quite often a community is a better place to go and look for an answer to a particular query. So what GraphRAG will do is it will take those summaries of the individual entities and relationships, and it will start to aggregate them up into community summaries. And a community summary can have quite a lot of information inside it that potentially could answer a particular query. And then GraphRAG goes one step further and it takes all those communities and it rounds them up as well into what it calls the global summary. And this is how it can really easily answer these more meta questions like what are the key themes inside the document? So it's got, the low-level nodes and entities. They roll up into the interrelated communities. I think it uses an algorithm called Leiden to do that. It's I did some reading on it that week. It's fairly simple actually. It's literally looking at around the nodes, how many connections are there between nodes, and then it kind of walks over the graph and recurses into it, and eventually picks out these separate communities. It's quite interesting to look into how it all functions. But then what GraphRAG eventually does is it builds an index. So very similar to my graph database, apart from it's a set of Parquet files on disk that get built. So you can go and peep into these and have a look, see all the entity graphs. But I found this really cool website earlier, before my screen reset, unfortunately, where you can literally go and upload all of your Parquet files. So if I just reveal this in the Finder, and I'll grab all of these, then I can take them and drag them into my upload artifacts here. And this will then show me what GraphRAG has built. So this is basically what it's extracted. And it's a view of the graph database. You can put all the labels on it, the color codings of the communities. So it's a really interesting way to explore it. And it's got a really cool like 3D view as well. It's like, which is kind of neat. So this is great. So we have all of these files on disk, and then the nice thing about GraphRAG is that there's a little Python SDK that we can use to basically query it. So we can query, for example, the global community. What paintings did Leonardo make? And we can query the local communities as well. And what I've done is these queries can take a little bit of time to execute. So I have gone and built them and run them in advance so you can have a look at the outputs of them. So again, this is literally vanilla GraphRAG. I've done no tuning of the queries or anything like that. The local query comes out with a few bits of information. I would say the local one in this scenario was, as good as the BaseRAG. And that kind of makes sense because the local ones is kind of at the lower level of the graph. But the global response is pretty cool. There's a lot of information that came out. Lots of good kind of summarization and information as well. And it's picked up a lot of works that have come out of that document as well. So, the results that we're seeing online are really good. Like there's some great examples on the GraphRAG website showing how it can pick up key themes and things like that in documents. And certainly my experimentation has shown that to be pretty good as well.
I often ask this of people, and when I was looking at the Microsoft GraphRAG accelerator, it says that it's meant for enterprises, and to be careful playing with that because it is meant for enterprises and it's going to be pretty expensive because it's turning on a lot of enterprise level services. What you did where you were just playing with it locally, is that something people can do cheaply, or do they still need to be really careful because of things like, I don't know, I guess Azure AI search can get pretty expensive, and if people turn on endpoints, that can be.
Right. No, really, really good question. So with respect to GraphRAG only uses Azure OpenAI or a GPT model behind the scenes. So it uses a open source database called LanceDB to store all of these Parquet files inside and run the searches. Where GraphRAG can be quite expensive is in particular these global queries. So to create a global query, if I recall correctly, it's either that there's quite a lot of smaller queries that are going onto the LLM, and they've all got quite a large prompt window inside those queries. I don't have the numbers here, unfortunately. So I think that's where you'd have to be more careful. The local queries run a lot quicker and put a lot less kind of pressure on the LLM itself. But those global ones can definitely chew up quite a lot of tokens. So be wary of those ones. But I mean, I've been playing with this. I've used a few dollars over the last week or so. So my manager, I don't think he's going to be chasing after me at the moment for using this one.
That's cool. So people can play pretty cheaply as long as they pay attention to what they're doing.
Yeah, exactly that. Just be wary of how much information you're indexing and how many queries you're passing through it. But just to run it over a single document and then try some queries on it, you're not going to put too much pressure on your costs. He says, disclaimer, scratch that from the record.
But it'll be worth it once they really understand what's going on there, and they're able to optimize their organization's apps built with AI, and they have the best app on the market. Then the opportunity is endless.
Yeah. I mean, there's so much power and knowledge inside the graphs that get generated, and being able to unlock all of that in response to a single user's query is really, really cool. And, once you've seen where BaseRAG starts to break down, I think that's the key, right? Is no one's saying throw BaseRAG out. BaseRAG is brilliant as long as that's the kind of queries you're working in. And if you're getting good outcomes from it, then there's no need to move along. But if you're suffering from the sorts of things we were talking about earlier, then, GraphRAG, and whether it's the Microsoft GraphRAG or Llama Index GraphRAG or LangChain GraphRAG, are all really interesting things to look at to see if that can help you move forwards with your RAG applications.
Yeah, I guess like everything, there's so much stuff to take into account, and everything is very good in its own particular use case.
Mm.
I was at a user group the other week and I was having let's call it a discussion with a guy who was saying that he had heard that you can just use the base model was this particular one. You didn't need any prompt engineering. In fact, they recommended against putting any prompt engineering in, and it was perfect the way it was. And I was like, well, yes. I mean,
Great.
for if you just want to use it in a very limited way to ask it questions and get answers out, that's fine. But if you were going to use any base model with your company's information, you would want to put some prompts in there. You would
Absolutely.
definitely
Absolutely. Yeah.
not leave it
Yeah.
as it is. But as it is, yeah, it's great for,
Yeah.
it's simple base cases.
That's it. Absolutely, absolutely. Yeah, it's all about, the moment you have more specific requirements over what the output can be, then you have to enter the world of prompt engineering. And, for me, it's like every application you see built on an LLM is going to be using some very crafted prompts. And the really cool thing about them is they're easy to look at. You can set up something to log those prompts. Most of the applications will log them if you want, or run like a debugging proxy. Have a look at the prompts, go and find them in GitHub, and you'll get inspiration for building your own prompts, because like everything, there are people that have spent a long time working out how to coerce the LLM to give the output they want. And if you can go and see how they do it and take that and use it in your own prompts, then that's going to get you much quicker to where you want to be. So yeah.
And that we do have Microsoft do have some very clear prompt engineering templates that will help you
Mm.
think about what you want those prompts to be. It has examples of those. It's put them in sections around, around grounding, around safety, around all sorts of I think there's 4 different sections that it goes through that I think are really, really useful.
Yeah.
And yeah, you don't want people doing jailbreaking or prompt injection attacks on your
Yes.
app. And so you want to be thoroughly prepared for that. And that comes from that combination of
Yeah.
doing your prompt engineering correctly and using safety and content filters and, other things
Yep.
that we offer. So I know that our developers out there are going to want to play with GraphRAG ASAP, just as I am. And it was really cool of you to give us this breakdown in each of the different stages, so that we can see how RAG has kind of grown and developed over has it even been a year? It hasn't.
Oh wow, yeah, it's so quick, isn't it? Yes.
It's amazing. So thank you, Graeme. It has been amazing to have you on the show. Your knowledge of the subject is only matched by your energy. And I know whenever I talk to you, I want to get straight into it. So I would like to thank you on behalf of everyone watching. And I know that everyone out there is equally inspired. Do you have anything you want to leave us with to like, where do we start, or where do we go?
Yeah, look, I mean, when it comes to GraphRAG, pip install GraphRAG, and then this Python statement that's on here. But, my one parting thing, I mentioned it a few minutes ago, would be with an LLM, it's always the prompt. Like there's no, the things themselves are magic, but the applications that built on them are a series of incredibly well-crafted prompts. And if you're ever wondering how something works, follow the prompts and you'll see what's going on. Follow the prompts.
Yeah. Currently, it is a whole career path. There are people out there answering jobs to be prompt engineers. I'm not sure that will continue. I think that it's probably a combination as we go on with like AI engineering and data science, and every job will have a little bit of prompt engineering in. But still, right now, you could be a prompt engineer if you if you put enough work into it. Cool. So you can find all of the resources for this episode on the GitHub blog, as Graeme said. And There's also like a bunch of, there's a research project and there are white papers, but all of that you can find from the blog that we've put in the resources. We have been answering questions online and we will stay online to answer them for another 15 minutes. So thank you all for tuning in and we look forward to seeing you next month.
Thanks, Michelle. Cheers. See you all. Bye.
Thanks, Graeme.